Hi, Dr. Raj here, and sleep disorder breathing, including physiology, is 20% of your sleep medicine boards. So today, I want to talk about chemoreceptors. So I think of them when I ask the question, what influences your drive to breathe? But before I answer that question, let's take a step back and talk about breathing in general. So is breathing an involuntary or voluntary process? The answer is it actually is both. Don't get me wrong, it's definitely involuntary. How do I know that? Because we actually sleep, and I love to breathe when I'm sleeping. Or when I'm in the ICU and someone's in a coma, they're still what? Breathing. But can breathing be voluntary all the time? How do I know that? Look at me. I'm holding my breath. What else? I could hyperventilate, I could hypoventilate, but right now let's talk about the involuntary process. So what influences the drive to breathe? It's going to be chemoreceptors, and chemoreceptors come in two types. There are peripheral chemoreceptors and there are central chemoreceptors. So where are the peripheral chemoreceptors? They love to be located in the aortic arch or the carotid bodies, and they sense two things. Number one, dissolved oxygen, which is the P, the little a, O2, which is the partial pressure of arterial oxygen, or the dissolved carbon dioxide, which is the P, little a, CO2, the partial pressure of arterial CO2. When we talk about the central chemoreceptors, where are they located? Well, definitely going to be in the brainstem. I like to say a lot of them are going to be where? In the medulla. And they sense one thing, which is going to be what? Dissolved carbon dioxide. And when we talk about the blood-brain barrier, dissolved CO2 can readily cross the blood-brain barrier. And when it's there, it gets turned into what? Into hydrogen ion. And why does it do that? Because of the fact it could actually stimulate our chemoreceptors in the brain to breathe. So as CO2 goes through the blood-brain barrier, it's making more hydrogen ion, making the CSF a little more acidic, and stimulating you to breathe. So what is the main drive to breathe? It's always going to be that rise of dissolved carbon dioxide. When does the dissolved oxygen receptors kick in? Is when you are very, very hypoxic. And what is a classic example when the peripheral O2 receptors kick in? Is when you go to high altitude. So those are going to be my pearls for your sleep medicine board exams.